Hello and welcome in video lecture series Demystifying Blockchain. In today's video, we will look at Bitcoin address generation. So if we look at the process of Bitcoin address generation, this is basically we take a private key and we apply some cryptographic algorithms, right? And some encoding mechanism. And finally, at the end, we get a Bitcoin address, right? So we will start from the beginning, right, from how private key public key pair is generated, right? Then how cryptographic hash functions are being applied to public key to get public key hash. Then what kind of encoding mechanism is being applied to get final Bitcoin address. All right, after understanding the whole process, we will have a very short demonstration and where we execute the code to just map our steps with the code that I have written, right? So after understanding the process, we will go to the code and see Bitcoin address generation in practice. All right. So the first step is to create a private key, right? Which algorithm is applied here is elliptic curve cryptography, right? So with the help of this elliptic curve cryptography, you get a key pair. Okay, so inside that key pair you have public key and you have private key. So this key pair is basically driven from random number, right? You assume that this private key is random. Then we apply elliptic curve cryptography multiplication under the curve SecP256K1 and this private key is converted to public key. Okay, after that we apply SHA-256 hash, right, cryptographic hash function. We have seen this in cryptography class, right? Now after applying SHA-256 we get $256 bits, right? After applying SHA-256 we have RIPE MD16. That's why we say this is double hashing, right? First we do SHA-25 hash, SHA-256 hash, then we do RIPE MD16 hash. So this is called as the output of RIPE MD160 is called as public key hash and it is 160 bits, that is 20 bytes. All right, so this you have seen in script pub key, right? The locking script that we have seen in locking and unlocking video. We have public key hash, so that is this hash, right? Now in order to make address compatible with either mainnet, testnet on any other network in Bitcoin, right? For mainnet we use 1 byte network ID as 00, right, in hexadecimal. And for testnet is simply a network that is very similar to the main network. The difference is that in testnet you don't require real bitcoins to play around, right? This is just for the development or practice, right? Suppose you want to test something, you can test on the testnet, right? So you will be 100% sure what is happening and how your transactions behave, how transactions look, right? Then you can move to mainnet. Fine. So after adding this 1 byte, so we have 21 bytes. We need to calculate checksum. Checksum is simple double SHA-256 hashing, right? First SHA-256, then again SHA-256. The output of SHA-256 is 256 bits, that is 32 bytes. Among the 32 bytes, we have to take only 4 bytes from MSB, that's most significant bits, right? But 4 bytes. So we add those 4 bytes to the previous step, right? This previous step, 1 byte public key hash and 4 bytes at last. Finally, we need to do base 58 check, right? What is that base 58 check? This is very similar to base 64 and the difference is we drop some alphabets, just like 0, you'll see it is very similar to O. So some of the alphabets that were ambiguous, they were just taken out. So after doing base 58 check, you get the Bitcoin address, right? You will observe, if you look at main Bitcoin legacy addresses, they start with 1, and if you look testnet Bitcoin addresses, they start with either M or N. So you will understand when we look at demonstration and we will see the code running. You will see when it looks 1, when it looks, when it starts from 1 and when it starts from m. Just revising again, we start from private key. We take this private key with the help of elliptic curve cryptography. We convert this private key to public key. We do SHA-256 hash. Then we do RIPE MD16 hash of the output of SHA-256. Then that is our public key hash. We just concatenate and put network ID. If we are looking for mainnet address, we will put 00. If we are looking for testnet address, we will put 0x6f in hexadecimal. Then in order to calculate the checksum, we do double hashing and get the 4 bytes from that checksum, 32 bytes, right? We get only 4 bytes from the checksum. And then we concatenate at last to the previous step, that is 1 byte public key hash and 4 bytes. Then final step is do base 58 check, that's even you can say base 58 encoding, and finally you will get the Bitcoin address. So we will move towards the demonstration and all of these steps will make sense for you, right? As part of practical demonstration, we will see lines of code that are doing cryptographic stuff, right? We have seen in Bitcoin generation algorithm, right? We have seen different steps starting from private key to public key, then SHA-256 hash, RIPE MD160 hash, right? Then some stuff regarding network byte concatenation. Then we do again for checksum, we do double SHA-256 hash. Then finally we do, add that 4 bytes from checksum, and we do we do base 58 encoding, right? First we need some libraries. One library is elliptic cryptography, right? Elliptic library that allows you to perform elliptic curve cryptography, right? So other are just like doing cryptographic hash functions, SHA-256, RIPE MD160, and other encodings just like base 58. So these are some libraries that you require, so you have to just import them and install as npm modules. So we start from private key. So here is the line that allows us to create the private key. So these are random bytes, 32 bytes. With the help of this private key, we create a key pair. Basically we create it in a format that is required for elliptic curve cryptography. Then we create a public key here, right? Here is the code for creating public key. After doing this, we take SHA-256 hash, then RIPE MD160 hash, right? This is for creating SHA-256 hash, and this line is for creating RIPE MD160 hash. So the output of this is called as public key hash, and this goes into the script when we create, when we try to send some bitcoins to some account. So we basically log log that value into a public key hash, and this is that public key hash. So this is very important for us to understand, right? Then we add network bytes. So let us, for this example, we do it for the main Bitcoin, right? So this is 00 for main Bitcoin network, and we have to concatenate it with the public key hash. Then we do double SHA-256 hash for creating checksum. So we have SHA-2561 here, SHA-2562 here, and then finally we create the checksum and take last 8 characters, right? Take first 8 characters, that is first 4 bytes out of the 32 bytes checksum. Fine. We concatenate this to public key hash with network prefix, right? So then we concatenate this with the network, we concatenate first 4 bytes of checksum, right, with public key hash with network prefix. So we have the new constant. I just named it based upon what they refer to, right? So that's a good naming convention. You will get to know about this public key hash network prefix with checksum, right? So what we have to do, we have to just concatenate checksum here because we have that variable, right? So we add at last checksum, and the final step, if we go back again to the algorithm, right? So the final step is base 58 encoding, and final step is base 58 encoding to the public key hash network prefix with checksum. So finally it will give us the address. Now wait, what we have learned in scripting for Bitcoin, right? Where we see unlocking and locking. In case of locking, what we do, we just lock it to public key hash. But here we are seeing that we have the address only because we don't know about the public key hash. So you can get easily public key hash out of the address. Basically what you have to do, you have to reverse the process, right? You have to do base 50 decoding of the address, and you have to just slice out the network byte and the last 4 bytes from the checksum. So what exactly I'm doing the same. So I am getting 20 bytes finally. That is public key hash. If you look at this, RIPE MD160 is 20 bytes exactly. So let us see all those steps in action, what they produce as an output. So for that I will try to run this code, and you can do it. This is JavaScript file. You could just simply run with node and file name, right? So my file name is bitcoinaddressgen.js. This is a JavaScript file. I hit run. Let's see what it produces. If you look at it, it gives the following answer, right? We have public key here. Out of this we get the SHA-256 value, RIPE MD160. This is our public key hash, right? This is important. This is our public key hash, and we add the network byte and do the checksum, right, with the help of double SHA-256, and this is our public key hash with network prefix and checksum, and we just pass on this information to RIPE MD. No, we just pass on this information to base 58 encoding, and this is the output, and this is the Bitcoin address. If we talk about specifically, this is the address for the mainnet, and it starts from 1, right? So this gives us validity because we just pass on 00 as prefix, right? So then finally the last line of the code was doing the reverse, that is basically base 50 decoding, and we are just slicing out our public key hash. If we look at this, after decoding we have this, and if you look at the public key hash, they are exactly same. So this is how wallets do it, right? When we try to send Bitcoin to other address, they basically decode it and put it into the locking script, that is script sig, right? That is script pub key, not script sig. Script sig is for unlocking, right? Now if we try to do exactly, if we have a look on what we have learned in terms of algorithm, right? So we have 0x6f for the testnet, right? So going back, let us pass on 06f, right, instead of this 00. So we will pass on 6f, right? And try to do one thing again. We try to run this just to see if it produces a Bitcoin address for testnet, and it should start from M or N, right? Hitting this, and boom, here we go. So this is the address now. It starts from M exactly. That is the requirement. So this was the goal for this video, in order to just explain you the process of creating Bitcoin address. Why we call this legacy address? Because there are some more forms of Bitcoin addresses, just like Badge32, and I will take all those advanced concept in advanced Bitcoin series, where we look some more advanced scripting methods, more advanced way of creating addresses, just like Badge32, right? And we will talk about some advanced concept there, like segregated witness, how that helps, right, in reducing transaction fee. Okay, so that is it for this video. I hope you love the content. If you really like the content, hit the like button and subscribe to the channel. See you in the next video. Bye bye.